inverses. Today we will talk about inverses of functions. So we know that something is a function if, why aren't you, come on, you can do it. I have faith in you. There we go. Inverse is a function. Something is a function if every x corresponds with a single y. And we're going to find out that the inverse of a function is also a function if every y corresponds with a single x. So let me give you an example. If I do x squared, so I've got y equals x squared. Okay, the process of finding the formula for an inverse starts with flip-flopping my x's and my y's. So I'm going to write this in red. And what we are going to do is say I've got x equals y squared. So I have flip-flopped my x's and my y's. And now I need to solve for y. So in order to get y by itself, I need to take a square root of both sides. And any time during the process of solving an equation that I need to take a square root, I cannot forget my plus minus. So based on what we did in the last section, what we have is y equals plus or minus root x. So a positive root x is going to look like this, and a negative root x is going to look like this. So basically, it is a sideways parabola, is what we have. So what I need you to do is pay attention to my my thumb. Okay, here is my hand, and if my hand is laying on top of my blue parabola, in order to find the red parabola, I flip-flop my x's and y's. So I did not rotate the blue function to become the red. I did not rotate. What I did was I flipped. So my thumb, which is currently in quadrant 2, okay, and my pinky, which is currently in quadrant 1, is going to flip. And so now my thumb is in quadrant 4. So this arm and this arm correspond. And then my pinky stays in quadrant 1. So this blue arm and this red arm are inverse friends with each other. What you also need to recognize is that every function and its inverse are reflections of each other across the line y equals x. Okay, so if you fold this thing across the line y equals x, which is going to be a really crappy fold, then this stuff will lay on top of that stuff. Okay, so actually let me fold it just a little bit better, just so it's a little bit easier to see. So if you were to do, oh heavens, all right, if you were to do this, and again, it's not a perfect fold, but this line is the axis of symmetry. Okay, so you would fold these things across these things. So if I can make that fold, then I know that they are inverses of each other. Well, that's great, fine, and wonderful if I've got a picture. But come back and look at what our test is going to be. So remember what I did was I took the blue parabola and I reflected it across the line y equals x. Okay, and now I want to know, is the inverse of functions. So now I'm dealing with the red thing. The red thing fails the vertical line test. The red thing fails the vertical line test. So I know from the picture that the inverse of this fails the vertical line test. Well, I need an easier way to do it. So let's just draw an arbitrary vertical line. There he is. Okay, and let's nail that thing down. So this vertical line is now nailed to the parabola that is red. And now I'm going to rotate it back up. So including the red line, if I rotate this thing back up or reflect it back up, what does this vertical red line become in relationship to the blue parabola? He becomes a horizontal line. Okay, so I've got the horizontal line test. So if we do the vertical line test, then I can say yes or no, it is a function. Okay, if I do a horizontal line test, same criteria, it can only hit the original graph once. then I find out if the inverse is a function. Okay, so do it to the original graph. In other words, I'm going to do a vertical line test on the blue thing. He passes. I'm going to do a horizontal line test on the blue thing. He fails, which means his inverse is not a function. Okay, so the last thing that we want to look at is how do I note this thing? So if I'm looking at the inverse, I could say the function, and let's just do x to the third. So this says the function of x is x to the third. Now let's do this real quick. What does this look like? He looks like this. Does he pass the vertical line test? Yes, he does, because regardless of where I draw a vertical line, he'll only hit the cubic function once. Does he pass the horizontal line test? Yes, he does, because of regardless of where I draw a horizontal line, he'll only hit the graph once. So not only is this an inverse, but his function is an inverse. So here's how we're going to solve it. I'm going to flip-flop my x's and y's. So remember, I've got y equals x cubed. So we'll flip-flop this into x equals y cubed. And now we're going to solve for y. So I'm going to take the cubed root of both sides. So I get the cubed root of x is y. Okay? Don't take a plus minus because it's not an even root. So now what I have is my original function and its inverse. So they both say y, so I'm going to change this to say the inverse of my function is the cubed root of x. So this little thing looks like an exponent. It is not. No, it is not. This says the inverse of my function is the cubed root of x. So what does the cubed root of x look like? He looks like this, and look at this magic. He is symmetric about the line y equals x. So we will come back and we will do some examples.